This lecture is on Dalton's law, concept, and applications. Dalton's law states that the total pressure of a gas mixture is the sum of the partial pressures of the gases in the mixture. P total equals the sum of all pressures of gases. An alternative equation is that one can find the partial pressure of a gas like PA if one knows the fractional composition relative to the mixture and the total pressure. It is PA equals XA times P total. Where XA is the fractional component or mole fraction of A, which equals the ratio between moles of A over total moles, volume of A over total volume, or pressure of A over total pressure. You could also use the ideal gas law where P equals nRT divided by V. For example, the partial pressure of CO2 is 56 mmHg and the partial pressure of N2 is 47 mmHg. If the tank containing CO2, N2, and AR has an overall total pressure of 143 mmHg, what is the partial pressure of AR? By definition, P total equals P of CO2 plus P of N2 plus P of AR. Therefore, since the total pressure is 143 mmHg, which equals 56 mmHg plus 47 mmHg plus P of AR, in the end, P of AR equals 40 mmHg. Problem 1 is, in a mixture of 0.200 mole of CO, 0.300 mole of CH4, and 0.400 mole of CO2, has a total pressure of 800 mmHg. What is the partial pressure of CO? Given that the N of CO is 0.200 mole, N of CH4 is 0.300 mole, and N of CO2 is 0.400 mole, if the total pressure is 800 mmHg, can one find P of CO? Yes, if one knows the total moles present in the system. The solution map is by first using the given moles of CO, and then one can get the total moles of the system and the partial pressure of CO obtained by using the ratio between moles of CO over total moles and multiply by the total pressure in mmHg. It turns out that the total moles after adding the moles of CO, CH4, and CO2 is 0.900 moles, and after taking the moles of CO, dividing by the total moles, and multiplying this ratio by total pressure, P of CO is 180 mmHg. Problem 2 is, in a gaseous mixture of equal masses of C2H6 and CO2, the partial pressure of C2H6 is 22 mmHg. What is the partial pressure of CO2? It is given that the pressure of C2H6 is 22 mmHg, plus the mass of C2H6 equals the mass of CO2. The question is, can one obtain the pressure of CO2? It is yes, if one can get the moles of both gases by using their respective molar masses. The solution map is by starting with a mass of the two gases and then using their molar masses to obtain the moles. Then, with the known partial pressure of C2H6, eventually get the pressure of CO2. Since mole fraction is proportional to its partial pressure, let's say that each one has 1 gram of both substances. In this case, there are 0.0227 moles of CO2 and 0.0333 moles of C2H6. The total pressure of the system is, after plugging in the moles of CO2, which is 0.0333, the total moles of 0.0560, and pressure of C2H6 of 22 mmHg, it is 37 mmHg. And according to Dalton's law of partial pressure, total pressure equals the pressure of C2H6 plus pressure of CO2. And after plugging in the numbers, P of CO2 is 15 mmHg. Some problems will involve collecting gas over water, and for these cases, you will need to know the vapor pressure of a water at a specified temperature. Here below are the partial pressures of water from 15 to 30 degrees, and it is used for systems involving two or more gases in which the gas produced is in water. Let's look at some problems. Problem 3 is the volume of the dry gas is 600 cubic cm at 25 C and 750 mmHg. What volume would this gas occupy if collected over water at a pressure of 746 mmHg and 32 C? It is given that the pressure of the dry gas for the initial is 750 mmHg, T1 is 25 C, V1 is 600 cubic cm, pressure of the wet gas for the final is 746 mmHg, and T2 is 32 C. One needs V2, which we can get the temperature in Kelvin units, and the equation for the combined gas law, which is P1V1 divided by T1 equals P2V2 divided by T2. The solution map is by starting with the temperature in Celsius units and converting to Kelvin units. Next, correct the final pressure of the gas obtained by subtracting the total pressure from the pressure of water at 32 degrees Celsius. Finally, using all P, T, and V1 to solve for V2 with the combined gas law. T1 is 298.15 Kelvin units, T2 is 305.15 Kelvin units, and P2 dry is, after taking 746 mmHg and subtracting it by 35.4 mmHg, the vapor pressure of water, the pressure of the dry gas is 710.6 mmHg. Once P1, P2, T1, T2, and V1 have been plugged in the combined gas law and solved for V2, it is 618.7 cubic cm. Problem 4 is a common method for preparing oxygen is the decomposition of KCl3. The reaction is 2KCl3 forms 2KCl plus 3O2. In an experiment, 0.250 L of oxygen was collected over water when the atmospheric pressure was 759 mmHg and the temperature of the water and gas was 14 C. Calculate the amount of O2 collected in moles. The vapor pressure of H2O at 14 C is 12 mmHg. It is given that the pressure of the wet gas is 759 mmHg. The vapor pressure of water at 14 Celsius units is 12 mmHg. T is 14 Celsius units, and V is 0.250 L. One needs to express the temperature in Kelvin units and need the ideal gas law in which PV equals nRT, where R is 62.4 mmHg L per mole K. The solution map is by first converting the temperature from Celsius to Kelvin units. Next, correct the pressure by taking the total pressure of the wet gas and subtracting from the vapor pressure of water at 14 Celsius units to get pressure of the dry gas. Finally, with the P, T, R, and B, solve for N with the ideal gas law. The result is that the temperature is 287.15 Kelvin units. The pressure of the dry gas after taking 759 mmHg, the total pressure, and subtracting by 12 mmHg, the vapor pressure of water, it is 747 mmHg. After plugging the P, V, R, and T values in the ideal gas law and solve for N, it is 0.0103 moles of H2. Here are some review exercises for you to work on. Solve each of the following problems. A, the following reaction is used to generate hydrogen gas in the laboratory. If 243 ml of gas is collected at 298 Kelvin and has a total of 745 mmHg, what mass of hydrogen gas is produced? The vapor pressure of water at 25 C is 23.78 mmHg. The reaction is solid Mg plus 2HCl AQ forms MgCl 2AQ plus gaseous H2. B, the following reaction generates hydrogen gas. If 408.0 ml of gas is collected over water at 20 C and has a pressure of 767.4 mmHg, what mass of zinc metal dissolved? The vapor pressure of water at 20 C is 17.55 mmHg. The reaction is solid Zn plus 2HCl AQ forms ZnCl2AQ plus gaseous H2. C, a 31.4 ml sample of nitrogen gas was collected over water at 23.7 C and a barometric pressure of 706 mmHg. What mass of nitrogen, or N2, was collected? The vapor pressure of water at 23.7 C is 22 mmHg. For the remaining part of this lecture are solutions to review exercises or problems. Please view only after completing these exercises.